Okay, great. So we will start, right? So, so again, welcome again to today's session, right? So today we will cover pond culture, right? So the last class we had, we would have gone into tank culture, and we would have explored different aspects of tank culture with respect to basically the different types of tanks we could utilize for production, the different types of filtration, mechanical, biological, etc. Certain things, design parameters, etc. We would look for in terms of um, size and like having proper biofilter material within the biofilters, the biofiltration process, etc. Right? So today we will basically go into the other type of system that is most commonly utilized here in Trinidad and the Caribbean as well, which is pond culture. Yeah. So we have two major types of systems, which is tank culture, pond culture. Right now, again, just to reiterate, there are different types of aquaculture systems that are utilized around the world, right? But again, here in the Caribbean, we kind of limited to the types that we actually utilize, right? So just as a refresher, um, aquaculture systems vary immensely. So they range from outdoor ponds to indoor tanks, sea cages, etc. Right? These systems can be extensive, semi-intensive, or intensive. Right? And the category depends upon the number of organisms grown per unit volume of water, as well as the water source and supply. Yeah. So pond culture is extensive. Cage culture is semi-intensive, but intensive within the cage itself. And recirculating aquaculture systems are intensive systems, and these are the systems that we stock the most heavily. So like in Trinidad, for instance, or in areas where we have very limited amount of available land or suitable land for pond culture, you would realize that tank-based culture would be the most preferred form of aquaculture, because if we really are to maximize on production and actually earn a decent enough income, right, we need to actually have a lot of production going. And if we don't have the land space for it, because like for pond culture, for instance, right, we would need to utilize more intensive ways of culturing organisms. And this is one of the major advantages of tank culture, right? It's a bit more costly in terms of your cost of production to produce a particular aquatic species in tank culture. But when you look at the long term in terms of growing more organisms per unit area, you kind of actually have a little edge over pond culture, right? In addition to that, with tank culture, again, you have more control over your water quality parameters, etc. So you can kind of tailor and keep your water quality parameters or the conditions for growth and development of that particular species to the optimum level. Yeah. So, again, there are slight disadvantages and advantages to each type of system, right? And depending on your situation, one may be favored over the other, right? So just as an example, China, for instance, which is the largest aquaculture producer in the world, like those Asian countries account for almost 80% of world production, and they they rely heavily on or they utilize a lot of pond culture because they have so much available land, right? They could actually put that into production while they're getting less production per unit area. They have real plenty area, so they could do it extensively. Their cost of production is very low in pond culture, right? So they could actually, so they're very competitive, so they could put products out onto the market at a much lower cost than it will cost somebody who is growing or whose major production system is tank based. Yeah. So that's kind of one of the reasons why China again is kind of leading the world with respect to aquaculture production. And if we look at locally here in Trinidad, we primarily farm the tilapia. But one of the challenges with tilapia is that we grow it mostly in tanks, right? Again, because of land restriction, etc. And because of that, our cost of production is very high to produce a tilapia as compared to simply importing products from China. Yeah. So it's a slight disadvantage to us because we're not very competitive in terms of when you look at competing with imports, right? However, a fresh product is always better, right? Because I mean, it is more desirable because it tastes better as well. It's also it's also of better quality as well because you have more control. You know the environment in which you're growing your product. But at the end of the day, when consumers go to Price Mart or they go to some of these different supermarkets, price in most instances dictates, right, what they purchase, right? And it's the fact of the matter is very competitive because they could produce things like fillets and stuff at a much lower cost than what we could do locally. So that's one of the major impediments to our local industry kicking forward, right? So this is why we really need to seek out one alternative species that we could culture. I mean, aquaculture is not limited to tilapia. There are many different things we could culture as well, right? And two, if we can increase our marketing to show the value of growing local, putting out local tilapia, right? The fact that they grow in more pristine conditions, etc., etc., we could actually have a better chance of marketing our local product, our local tilapia at a higher cost than what you would pay for imports because people would now be paying for quality. Okay. So again, these are some of the major production system categories around the world: tank culture, pond culture, cage culture, and raceways. We would have touched on this before, right? And again, two major types of systems, just as a refresher: tank culture, where we're growing in tanks. We have a filtration mechanism in place, both mechanical, biological. So we were using the water, we're sending it through different processes, and we're growing our fish within that particular system. Pond culture, which is more extensive, we just kind of have fishes out in open ponds. But again, pond culture is not simply pond culture is not simply digging a hole in the ground and putting fish in it. Yeah, there are certain criteria and conditions that need to be in place to be considered growing fish in a aquaculture pond culture type environment. Right? So ponds. So ponds are broadly defined as earthen impoundments for holding aquatic species. They are the oldest aquaculture structures because of the simplicity of basic pond culture in freshwater, right? So pond culture can be undertaken with nothing more than convenient natural ponds, right? And ponds tend to have the lowest stocking densities of the culture structures, right? So out of all the different type of culture systems and stuff that we would have, again, pond culture is the one with the lowest stocking density, right? So again, to reiterate, areas or countries where we have limited space, you wouldn't find much pond culture being done. You will find more the tank culture and different alternative types of culture structures. Right? So again, purely harvesting from natural ponds is not aquaculture, right? So again, if you go back to the definition of aquaculture, you must have some means of enhancing production, yeah, to be considered aquaculture, right? So basically just harvesting from a natural pond is more or less what we know as traditional fishing because it lacks the component of enhancing production, right? Example, with pond culture, you add fertilizers to enrich the culture environment. So you get algal blooms. So the algae helps regulate water quality, depending on what type of fish you culture, and they can feed on the algae as well. So you have some sort of intervention there. So that is considered aquaculture, right? If you remove predators, competitors for the cultured species, right? Again, you are basically interjecting within that culture environment. So just the simple act of doing that is also considered you doing aquaculture. Right? So cheap, simple ponds are the most widely used freshwater and brackish water aquaculture systems. Right? So again, ponds are the most commonly cultured for culture of fish, commonly used for the culture of fish and crustaceans. Right? So again, the cheap, simple ponds are the most widely used freshwater and brackish water aquaculture systems. Right? So examples of different types of ponds. You can have a sunken pond, which is a simple hole in the ground, right? You can have a barrage pond, example, an enclosed waterway in a valley or stream bed where only one or two walls are constructed. So just imagine you have water flowing through a valley, right? So you block off the front and the back because the two sides, you would have the sides of the mountains or the hills, right? So that's called a barrage pond, right? And then you can have an embankment pond, which is an above ground pond. And this is one we would focus a lot going along in this lecture today, right? So there are some certain requirements for ponds. So the main requirements for ponds are one, a reliable supply of good quality water, right? Relatively impermeable soils for construction. So imagine you're constructing a pond, right? So you're dependent on the pond to basically hold water. So if you just think about it, sandy soil, well, is really not suitable for pond culture. Yeah, because you want to have soil which is relatively impermeable. So when you construct that pond, it will retain the water. Yeah. So well structured soils with good organic matter content to support pond ecosystems is also a good requirement for ponds, right? Because they need organic matter. Because with pond aquaculture, right, one of the key things is actually enriching that water within the pond, so you will get algal blooms. And these things help regulate water quality, it acts as food for certain types of fish, etc. Yeah. And another requirement for ponds is that you must have some mechanism for gravity drainage, right? So in certain ponds, like the above ground ponds, like the embankment ponds, right, we will depend on gravity to drain these ponds when it's time to harvest, etc. Right. So site considerations. One of the most critical considerations for an aquaculture enterprise. So these are some of the different parameters we would look at when we consider a suitable site to set up our facility, right, or our ponds, right? Water, soil, topography, the type of pond that we utilize and the cost, right? And then when it comes to construction of ponds, right, there are two major types: levee type ponds, which is the above ground ponds I spoke about, and line ponds. Right. So the first thing we're going to touch on when it comes to pond culture is water, right? So access to good quality water consistently and reliably is imperative, right? So both quality and quantity. Distribution of water around the site must also be considered, right? And if possible, consider sites that already have access to basic infrastructure, such as roads and power to reduce initial setup costs, right? So water could be sourced from via rainfall, groundwater, such as springs and wells, surface water, streams, rivers, as well as runoff. Now you need to be particularly careful about surface water because these are about the most polluted water that we can come across, right? And especially so in Trinidad, there's very limited amounts of surface water that is of good quality for aquaculture. Yeah, because if you look at Trinidad, for instance, right, you do a typical drive around, there's a lot of agriculture taking place. Yeah, a lot of urban developments, right? So basically, you want to limit as much utilizing surface water as much as possible because it can become very easily contaminated. Municipal water is also another option, but when you're looking at extensive culture such as pond culture, the amount of water that you will typically need, right? It may not, municipal water might not be a best option. Okay. So water again, so quantity is you must have sufficient amounts of water. It should be available year round, right? And it should be sufficient to fill the production unit and cater to daily losses via evaporation and seepage from the ponds. You must have good quality water as well, right? Because with good water quality, you would ensure maximum production, right, of your aquatic species. In addition to that, it will be free of contaminants, whether it is pesticides or disease-causing organisms, etc. The soil for your ponds, right? It must be of a particular type of soil. It must be of a particular quality as well, right? So assessment of the soil is very important, right? Especially when you're going about selecting sites to construct your ponds, etc. Again, like what I mentioned before, you don't want to select an area that is very sandy, it wouldn't be able to retain water, etc. Clay soil is the most preferred soil type, right? Because of its ability to be compacted and retain water, right? Again, it is the soil at the site that will determine the natural productivity of the pond, water holding capacity, fertilization requirements, water quality, as well as construction. So again, clay soil is the most preferred, right? So poor site selection will result in ponds that cannot be managed to suit the requirements of the cultured animals, or that require an unacceptable level of inputs and maintenance to do so. So you really don't want to utilize or select a site where, like let me say for instance, the soil is not very clay, right? And it's more sandy and it's not retaining water well, right? So you might have frequent, the water will drain out a lot faster. You might have to do a little more work with respect to trying to compact the flow. So you want to kind of avoid setting a system in place where you have to do frequent maintenance more than necessary. Okay? So site selection is key with pond culture. And again, if you look at Trinidad, we don't have a readily, like we don't have extensive amount of land available for pond culture. If we do have available land, it may not be suitable to set up ponds. Because again, apart from having land, the land itself had to be of a particular quality in terms of being clay versus sandy, etc. So you see, with choices for setting up for sites to set up ponds is very limited. So that's why again another reason why pond culture is not very popular here in Trinidad. Yeah. With tank culture, we can basically set that up anyway, don't matter the soil type, irrespective of soil. Yeah. So the main physical soil properties important for aquaculture use are physical, right? In terms of texture, strength, stability, water holding ability, physiochemical, ion exchange capacity, acid alkaline reaction, leaching effects, and absorptive binding capacity, biological, organic matter, and nutrient transforming biomass, right? Clay content, right? Take samples at various locations where soil retention characteristics are not good. A core of clay must be added, right? And extended below the level of the pond bottom. So basically, if it is you have an area that is not very sandy, a kind of intermediate between clay and sandy, so it's kind of suitable enough to do pond culture, it still probably will not retain the kind of water we needed to retain to set up ponds. So what we could do with an instance like that, in an instance like that, we could actually lay the bottom with clay and compact it and roll it within the bottom so that it will seal the bottom and we could be able to utilize it for aquaculture production. Okay? And with soil as well, we want to test it to make sure that it doesn't have any residual pesticides, etc. Because it will make sense we set up a pond, and then when we fill it with water, we have pesticides, etc., leaching into the water, which could cause basically it could cause our fishes to become exposed to these pesticides and become and die. So when it comes to pond layout, we have four main configurations or layouts of ponds. We have series, where ponds are constructed consecutively so that water flows through each pond prior to its discharge. This allows for easy movement of stock from one pond to another, and it maximizes the use of water, right? But a major disadvantage this is a decrease in water quality through consecutive ponds. So imagine you have 5 ponds, one after the other, and you have water flowing from pond 1, right? So series means it flows from pond 1 into pond 2, into pond 3, into pond 4, into pond 5. And because of that, when the water flows through, it takes with it metabolites and waste that the aquatic species produces within that pond. and it takes it from one pond into another pond, into another pond. So you realize while you're moving down along the chain of ponds, right, the water quality becomes in succession, it becomes deteriorated. Yeah. So that's one of the major disadvantages of having ponds in series. So it's not something that is really promoted or really sorted out. Parallel, however, water is distributed from a common supply and supplied into each pond individually. Yeah. And this is one of the more popular methods or popular configurations of laying out ponds. Yeah. You also have a radial layout where ponds are constructed so that each inner pond feeds into multiple outer ponds or larger outer ponds in a concentric pattern. This is not very popular in the Caribbean as one of the least utilized layouts of ponds, right? So you don't really pay too much particular attention to this particular layout. What we should really focus on is the parallel layout, right? And then we have inset ponds. So basically, these just kind of sensitize it to the different layouts. But again, the parallel ponds is what we would give major focus towards, right? With the inset pond, one pond is placed inside another larger pond, right? So this method is used when a nursery pond is set inside a ground pond, right? So basically, it's like a small pond within a large pond. So the large pond we have, let me say, for instance, we have breeders. We have tilapia, we have tilapia breeders. With the inset pond, we utilizing the same pond water, etc. But we kind of have a smaller area within the larger pond where we'd have like juveniles for growth, etc. Yeah. So pond size and shape. Ponds are usually rectangular to allow for maximum utilization of land, right? So the length to width ratio is usually 2 to 3 to 1, right? When we say length to width, so there's a certain length you would have, and based on that length, you would have a recommended width that the pond should be. Yeah, so that's what we talk about length to width ratio. Factors governing size of the ponds are the biological requirements of the culture animals, as well as access to the pond for husbandry. Yes, so basically, if you have a excessively large pond, right? So let me say the width is very large, the length is very large as well. Accessing that pond could become difficult because when it comes times to harvest, etc., it can become very problematic. Yeah? And a disadvantage of larger ponds with greater biomass and higher feed input is that they may become more difficult to manage. Yes, so you really want to have a size restriction on the size of ponds that you have for logistics, obviously. Right, another aspect of pond culture is topography, right? So if we look at slope, you want to select land with a gentle slope. Somewhere between 2 to 10% is the best. Why we want land with a gentle slope? When it comes to harvesting, remember I told you all we want to be able to drain ponds by gravity. All right. So for the easiest way to basically to facilitate that, right, is by basically constructing ponds with a gentle slope on the bottom. So if we have a drain out at one end, the lowest end in a pond, right? And let me assume that the pond has a slope with the lowest end being where we have the drain out. When we open that drain out, now we will see photos a little later on, right? When we open that drain out, the water will start to exit the pond, right? And if it's on a slope, you realize the water now would leave the shallowest end and it will move towards the deeper end, right? So when that water is exiting the pond, all the fishes that within the pond will move lower and lower and lower and lower into the deeper end, right? So basically you can concentrate all your fish or all your aquatic organisms in just that one particular area. So as opposed to taking a net or taking a seine and you having to go and seine a big pond because you really can't see what's going on in a little pond. So you kind of just relying on hope when you're actually going with your seeing and you're seeing and seeing and seeing, right? It's more labor intensive, it's not as efficient, right? However, if you are able to drain that pond and concentrate all your fishes in the deeper end, it's much easier now to come at a hand seine in that restricted area and seine out all your fish. So that is why having a gentle slope, right, topography could also help, and it actually benefits you as an aquaculture farmer to have a pond with that slope in place, especially when it comes to harvesting. You want to avoid areas that floods, right? So do not build on a floodplain. So places like Carney, right? Greenvale. If you will remember, just like maybe like a couple years back, the major flooding that we had, all the highway by Carney and stuff flooded out. So imagine you have an aquaculture facility in a floodplain like Carney, and every time we get flooding, that entire area floods out. You really don't have any good production going to take place there because you're going to lose all your organisms, all that you're culturing. So you want to avoid areas that floods. Yeah. So you want to make sure and investigate the site before you go about basically establishing your aquaculture ponds, etc. So pond construction. So we could have dugout ponds where we just dig a hole in the ground. But again, as I mentioned before, what we should focus on is the more of the kind of above ground type, levee type, or embankment type ponds is the most common form. So again, we will get a little bit into that in more detail shortly. So with respect to pond construction, right? So we have square ponds, rectangular ponds, circular ponds, and irregular ponds. So that are the different types of shapes that we could utilize. The pond bottom could be compacted, it could be regular, it could be sloped. And the harvest basin could either be external or internal, and we will get into the harvest basin shortly. Basically, depth of ponds in temperate countries, that's countries where we have different seasons like winter and summer and different things like that. You typically would have ponds on average 2 to 3 meters deep. In the tropics, right, the depth of ponds will typically be 1.5 meters deep, yeah, which is significantly shallower than in temperate countries. Right. So as I said before, the levee type ponds are the most common, right? And this is basically a profile of a levee type pond, a cross-sectional profile, right? So if we look at the colored photo to the top, where the mouse is pointing, right? So the blue, the light blue area is really the water, right? The green area, right, is basically something called the dike, right? The shallow end, the inner end of the dike slope is basically the kind of brownish area we see in here, right? Let's see what I did. Yeah. So basically, the dike is basically the area basically encompassing the water in that pond, right? So when you're dealing with a levee type pond, right, you basically have an embankment around a water body. Yeah, and these are just the names that we basically assign to the embankment, etc. Yeah. Right, so this is a cross-sectional area of a levee type pond again, right? So basically this dike we see in here, yeah, so this line diagram basically giving us some dimensions into the dike. Right? So levee pond construction, freeboard and depth, right? So basically the freeboard, if we go back to the pond here, right? So the freeboard is the area between the top of the dike and the maximum height of your water level. That is called your freeboard. Yeah, so it's basically the space between the top of the water and the top of the pond. So that's what we call the freeboard. right? So basically with ponds, they want to have about 1 to 2 feet of freeboard, right? So the depth, 3 feet in the shallow end and 6 feet in the drain end, right? So that's typically the depth of the water in the pond, right? So such depth allow for adequate light penetration for primary production and enough depth to reduce temperature fluctuations while decreasing the chance of both oxygen and temperature stratification. So basically, when you have a pond, remember you want to have the bottom slope. So one end will be shallower and the other end will be shallow and the other end will be deep, right? So when you're draining it from the deep end, the pond, the water will flow and it will exit the end with the drain off, and all the fish will be concentrated in the deeper end. So typically the shallow end, right, shouldn't be anything less than 3 feet deep, right? And the drain end should be around 6 feet deep. So in a levee type pond, the entire pond will not be the same height. Like some swimming pools and stuff like that as well. You would go from the shallow end to the deep end, right? So levee type ponds are similar to that. You start off at the shallow end, and then while you go along the pond, it gets deeper and deeper. So the shallowest part of the pond will be about 3 feet, and the deepest part will be about 6 feet. Yeah. So if you go to think about it now, right? If the shallowest end is 3 feet and the deepest end is 6 feet, and then the 6 feet end you have your drain off for the pond. So when you open that drain off and the water starts to exit, the 3 feet end will eventually go straight down to having no water, right? And then it will keep progressing like that until you do retain some water in the deep end. Yeah. And and that's where you will concentrate all your fish, etc., for harvesting. Everybody following my water? Any questions on it? Okay, good. So if anybody have any questions, again, please feel free to ask while we go along, right? So I can explain. Yeah, or if you want, we can just ask the questions after, and we can go back to the slides. Right. So again, these are some points on the slope of levees. All right, 3-to-1 minimum, 4-to-1 maximum. Right. So each meter of height needs 2 to 3 meters of horizontal distance. So again, your levee is also called your dike. Your dike is also called your levee. So it's an interchangeable thing, right? So basically, just to explain a little better, right? So the dike top here this is also called your levee as well, right? So basically, for the higher you go, right, the greater the slope is on your levee, right, the wider the top needs to be. And this allows for structural integrity, right, of the walls. So imagine that this becomes very steep, right? It's steep, 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 and the top here is not suitably wide enough. It could fall apart very easily. You can't really move about on top of it, etc. So that is why I have a certain slope to width ratio for your levee or your dike. Yeah.
Almost like long-term rice field.
Correct, correct. You are right. Yeah, so again, yeah. So it works with a similar principle, right? So you need to have a certain width so you can be able to move about on top of it, etc. Right. So levee pond construction. Size. Larger ponds are cheaper per acre, right? So again, it's cheaper to produce a bigger pond, to dig a bigger pond, as opposed to several smaller ponds. And that's pretty straightforward. Yeah. Because there's a lot more work to build several smaller ponds as opposed to one pond. Yeah. So shapes, the most popular types are square and rectangle, right? And the levee width, 20 feet for the main levee and 16 feet for the others. So if, for instance, you have, right, so let me say, we look at this thing. Look at the top photo, right? So these are levee ponds. This is the main we're talking about here. right? The area that you will be moving vehicles, because and when you're dealing with pond culture, you don't walk and when you're talking about you're walking and you're taking feed from a bucket and you're just throwing it and you're feeding your fish, right? Most of the times you're moving on vehicles, right? And you're broadcasting feed throughout these ponds because it's not feasible. It take you too much time, too much feed to move and just like be feeding your fish while you're moving. So you actually have to have basically come like roads they have now, right? Which is the top of the levees. That's why I say they need to be a certain width, etc. So the major levee I have connecting different ponds is called a main levee, and that one will typically be wider than the other levees. Yeah, because they are the most traffic on that one. So that is what I was referring to with the levee with 20 feet minimum for the main, right, which is the main levee that vehicles will be moving on, etc., and 16 feet for the others. Vehicles will still be moving on it, but the main levee is where you have major traffic throughout your facility. Right, so these are some photos of levee pond construction. Right, so it's plenty big machinery, your mill dig, your compact, right? You have excavators, etc., backhoes, right? So there's a lot of work that goes into these ponds. So this one newly constructed pond will look like. If we look far to the left, we're seeing something blue, so that's our existing pond, right? So you see the levee or the embankment that in between the new pond and the quote unquote old pond. Yeah. So this will eventually be filled as well. So these are how levee ponds are when in use. So these are several levee ponds together. So this is how pond culture is done on the international forefront. We don't have anything like this in Trinidad. We have a small level of pond culture, but nothing on this scale, right? So in this facility or this aquaculture facility here, if you look in the middle, you would see something looking like little white tops and well. So that's actually like the offices, the feed rooms. That's the facility itself, and it's surrounded by ponds. Right? So when you have your levees, right, they can either be graveled or non-graveled, meaning when you set up your ponds, right, it's advisable to run gravel on those levees in between ponds. If you look at the bottom right photo, if rainfall or when rain falls, right, and you have to run vehicles and stuff on that is what can happen. Comes very muddy because remember it's clay type dirt you're targeting to use for these pond constructions, right? So when it is you set up in these areas now and you just rolling on on bare dirt, bare clay, that could be the result. So you want to make sure that you gravel your levees and stuff like that. So you have free flow of traffic on it without any problems. No mud or anything like that, no sticking up, etc. So when you're angling your ponds, right, you want to angle them at right angles to the prevailing wind, right? The reason why you angle them at right angles to the prevailing wind is because they want to reduce the amount of erosion on the walls of your levees. If they're not at right angle, when that wind blows on that pond surface, right, it will create current within that water and it will basically hit against your levees and it could cause a significant amount of erosion. So orienting it at a right angle is actually prevent is exposed to the least amount of wind erosion. Yeah. And also when you have the ponds oriented parallel, it increases wind action as well as aeration as well. So when you're preparing your sites for your ponds, right, you want to make sure and remove vegetation and the topsoil because topsoil is very loose, right? It has a lot of it has a lot of loose organic matter as well too, so it wouldn't really be compacted and it wouldn't retain water well. So you want to scrape out the vegetation, you want to scrape out the topsoil and compact that area. Compaction is critical. Because if it's not compacted, it wouldn't retain water. And if it don't retain water, it just be a hole in the ground, it will no longer be a pond. Right. So when you have ponds, you want to make sure and be able to drain those ponds. Yeah. On the deep end of the pond. Remember, I told you all that in a typical levee pond, the shallow end will be about 3 feet, the deep end will be about 6 feet. Right. So in a typical pond, you want to drain it with about at least a 6-inch pipe. Yeah. So typically 6-inch pipe is sufficient for ponds less than 10 acres. Yeah, so anything less than 10 acres are around 6 inches. Anything more than 10 acres, right? You need something bigger than 6 inches or multiple 6-inch pipes because it's a lot of volume to drain and you wouldn't get sufficient flow rate from a 6-inch pipe. Yeah. So if ponds must be drained to harvest, example, when you're dealing with shrimp, right? So it's easier to harvest fish from ponds than it is to harvest shrimp from ponds if you do drain it. Yeah, because well, you do realize shrimp, well, that's the behavior of the animals, etc. Imagine you have a pond and you're not draining this pond to harvest it. You decide to use a seine and you're moving through that pond. With the shrimp, they will jump, they will move all around with it. It's very difficult to harvest those shrimp. So especially when you have ponds and you're growing shrimp in those ponds, you want to make sure you have a drain out and you have this pond with a shallow end and a deep end so you could concentrate all that shrimp within that harvest basin. So you could just pass easily and be able to basically take everything from it. Right, so again, pond drains, etc. You could use PVC pipe, right? You use an anti-seep sleeve around the pipe, right, deep in the levee. So an anti-seep sleeve prevents the water from exiting through the drain out. Right. So these are some examples of pond standpipes. So these are actually so the external pond standpipe, right, is connected, right? So this is on the first photo, right, which is labeled as external, right? So the bottom of this external standpipe, it's connected to the drain out inside of the pond. And you see this little red cap to the top, right? So when you unscrew that cap, the water will drain. The water will drain out from the pond and exit from inside of that cap, from inside of this pipe here. So this actually capping in and keeping in the water inside of the pond. So as soon as you open it, the water will drain out of the pond. Yeah, right. And then you could also have an internal with a swivel joint. So you see in this pipe that laying down it. So this one of the drain outs, right, is actually inside of the pond itself. When we say swivel, so that means that there's some sort of rotation, some sort of movement. So it's not 100% visible, but in the middle here, you all are seeing something looking like a partition in the pipe. So that's the swivel joint. So basically, in this orientation, the pond is in drain out mode, right? If we would call it that. So basically, all the water from the pond is already exited. However, if we want to refill this pond, what we would do is simply raise up this pipe that is lying on the ground horizontally here. So it swivels at the joint and it raises up. So the pond could now fill with water. And when we're ready to drain, we would push it down. So it moves at the joint here. Yeah. So it goes down into onto the pond bottom and all the water exits. When we're ready to refill, we just raise it back up. So the water in the pond could be filled back to the level at that drain out. Yeah? So that's our internal with swivel joint drain out pipe, standpipe does be like. And the first one is the external one. So the external one is fixed and we just had a cap to open and the water will drain out. Yeah. But the other one, we could actually raise up that standpipe in the middle. When we're ready to fill it and when we're ready to drain it, we push it down. And the joint in the middle here, the swivel joint, allows for it to move down and up. So water supply inlets and drainage system outlets. Right? So basically the inlets is what brings the water into the pond. The outlet or the drainage system for the outlet is what removes the water from the ponds. So those are some of the things, like those standpipes who I just spoke about, that's part of the outlet. Because their function is to remove water from the pond. Okay? So inlets and outlets are important components of ponds and need to be secure, easy to operate, and adequately sized. Right? The exchange of water through a pond is controlled via the inlet. Inlets may be pipes, channel, or sluices, and a sluice is basically an artificial channel for conducting water. So flow through the inlets could be regulated by using valves. So like a typical pipe that you typically have, like a faucet, you just turn it up, and the more you open it, the more water will flow out. So for your inlets, again, you just have a pipe with a valve, so you can, the more you open it, the more water will basically enter into it. Okay? In some ponds, right, water must be filtered to prevent the inclusion of organisms. And these organisms could be predators, competitors, or vectors for disease, right? So again, it all comes back down to your source of where you get your water from. Yeah. So if you're using like a natural catchment, or like let's say you're using a spring water, for instance, or water from a well, you don't really have to worry too much about predators or competitors or vectors for disease with your water source being wells or springs. Okay. However, if your water source now is streams or surface runoff, like let me say for instance, you're tapping off, you have your ponds, your aquaculture ponds, and you're getting water from a nearby stream. And that stream, the water could be contaminated because that water flowing through from different areas and then passing by your pond. It could have other fish and shellfish, crayfish, etc. within that water, right, living naturally in there. And these things can be vectors for disease. So you can have fish with parasites, you can have them with disease, etc. And when you allow that water to flow into your ponds, yeah, if those organisms enter into your ponds, they could come in contact with your fish, and they could spread their disease to your fish. Yeah. So that is why if you have ponds that the source of water that you're using to fill these ponds are from streams, etc., you want to make sure that when that water flowing in, you screen it so no organisms can get into your pond. Yeah. So again, your inflows should have valves on them to regulate the water, right? So if we look at the first photo to the left, that's water filling a pond, right? And if we look to the right, we would see a cap on it. Yeah. So basically, when you turn this cap, right, it kind of moves away from the seal, and water basically enters into the pond. I want to tighten it. So it's just a different, it looks different to like a normal valve you would have on your pipe, but it functions the same way. You just turn it, it increases the amount of water, and then if you close it, it locks it off. So your outlets serve a number of functions and are used to adjust and hold the water level, right? So if we go back and we look at the swivel joint that I showed you all before, where you can push it down and the water will exit, and you raise it up and it will retain the water. Yeah. So depending on how you adjust that, right, you can adjust the amount of water or the water level within your system. Yeah. So let me say you have the swivel joint and you want to drain your pond to half the level that it is. You basically push that swivel joint down till that outlet is at the half mark. And then when the water basically reaches half level, it will stop flowing out. If you want to completely drain it, you push it all the way down. Yeah. So another consideration when you're setting up ponds is to have an electrical source, right? For each pond, right? It's recommended you have one for each pond. Now, this is dependent on the type and the size of ponds that you have, right? Now, the reason why you want an electrical source for ponds, etc., if you have some ponds, people use artificial aeration, so aeration devices, and some of these devices to add additional aeration into the ponds would require electricity, etc. Yeah. So you want to, so in ponds where you're utilizing those type of devices, you want to make sure you have a power source close by, and it's always best to have one for each pond, depending on the size of the pond. Another thing you could do with ponds, instead of just, so let me say for instance, things real rough, and you really can't find good soil, or you really want to do aquaculture, pond-based aquaculture on some available land that you have, but the land is not 100% clay, and it's not very suitable to dig in ponds or setting up a levee type pond, right? Another thing you could do, you could actually line the pond. So you're digging out your pond as usual, but you're not dependent on clay to compact the bottom, etc. anymore. What you could do, you could take liner. So it's this kind of rubber type, HDPE kind of material, and line the bottom and the sides, and this will retain water. Yeah, so you can make it just put a skin within the pond itself, and you can fill it up and you could grow your fish. So this is line ponds. Yeah, so it's something it's something to consider as well. So plenty aquaculture farmers who are not who don't have suitable land, and they can't just do like a normal natural pond. What they will do, they would dig out the pond, everything to the specifications, and then just line it so it will retain water, and they can be able to basically do aquaculture. Yeah, and these are some examples, a photo showing some line ponds. If we look a little further down here, we're seeing within these ponds, we're seeing these little blue rectangles. So those are what we call happers, right? So it's basically cages that you can build with netting and put within your ponds. And in those cages, we could have juvenile fish, we could have breeders, etc. And then in the rest of the pond, we could have the fish that we're growing out for consumption. Right, so these are some basic steps into how to build a fish pond, right? So site preparation, right? You're going to remove trees, bush, rocks, etc. Cut the grass in the area, plan for pond construction. Get rid of that. Remove the top layer of soil containing roots, leaves, and deposits. And deposit this outside the pond area. So you kind of want to get rid of that, right? And you use when grass is to be replanted on the embankment. So basically, you see like your levees, when you gravel it, if you're not graveling it, what you could do, you can plant back vegetation on it, like a lawn kind of way, right? So basically, what you could do when you remove your topsoil from the area that you dig in your pond, you could use back the topsoil now on top of your embankments to grow grass because it's rich in nutrients, etc. Yeah. So again, when you're digging ponds, etc., you had to scrape using a backhoe until you reach the required depth. So backhoe would give you a very good scrape and leveling on your pond bottom. Yeah. So that's it basically there for pond culture, right? Do we have any questions on what we covered?
I guess nobody gonna ask, so I will ask one.
No problem.
The um, the big difference with this, besides the size, you said in tank culture the water can be reused for like aquaponics. It can be used for plants,
Correct. Yeah.
but with pond culture, because of the algae and then the possibility of contaminants and so on, you can reuse this water when you drain it.
No, you can't reuse it. Because what happens, right, especially with pond culture, you have a whole different type of microbial community within the pond, right? So basically in the sediment and thing, you would have different microorganisms and all of these things. So nutrients and stuff are no longer available like you would have it within a tank-based type system. So you can't use it back for aquaponics or anything like that.
Thanks.
No problem. Any other questions? All right, nice. All right, good. So let me just take a little 5 minutes break. And when we come back, we will start with the next lecture, which is water quality. Yeah. So it is 5:03. So let me call it at 5:10. We will resume and start the other lecture. Okay, good. So we're back. Right. So the other lecture I'd like to cover today, or rather start today, is water quality. Right? Now, water quality plays a significant part in terms of, right? Yeah, so water quality plays a crucial and a very critical role in aquaculture production, right? And as we go along into the presentation, we would see exactly why, right? And again, there are several different types of water quality parameters and variables, and each particular aquatic organism has a certain range that they operate and they function best at. So we as aquaculture farmers or aquaculturists, our goal is really to maintain water quality parameters, right, within the desired range for that particular species that we culture, right? So when it is, you look at all the different components we would have covered when we did tank culture. So we had the fish tanks, we had mechanical filtration, we had biological filtration, we need to convert ammonia to nitrites to nitrates, we need to add aeration with the air pumps, etc., etc. What all of these things actually, the purpose of all of these is really to maintain your water quality and to keep the parameters within the optimum ranges for the particular organism that you're culturing. Yeah. So your biological filtration component will basically convert your ammonia to nitrites to nitrates. So ammonia and nitrites are toxic to fish, right? And those are two water quality parameters that can have detrimental effects on aquatic organism. Nitrates, not so much so, right? So again, your biological filter is really just a way to maintain your water quality. Mechanical filter, the same thing, um, same purpose. It helps to keep that water quality within a good range, right? The aeration system, right? So when you add dissolved oxygen within your system, aquatic species or organisms need dissolved oxygen to survive, right? And dissolved oxygen is also a water quality parameter. So realize everything is really about just keeping your water quality parameters at the optimum level for your organisms. Okay, right? So these are some of the different water quality parameters and topics that we would cover, right? So we have a general introduction, temperature, DO, etc. So while we go along, we would see the importance and the relevance of these water quality parameters and the impacts it could have on our production. Right. So aquatic animals are healthiest and grow best when environmental conditions are within certain ranges that define for a particular species good water quality. So it's really a relative thing because what may be good for one organism could probably not be good for another organism. Yeah. So again, it's very specific, right? But there are certain benchmarks that is more or less standard across all organisms, whether freshwater or saltwater. Yeah. For instance, dissolved oxygen, right? All organisms need a certain amount of dissolved oxygen for growth and development. So it really doesn't matter so much so between species, etc. However, some species could tolerate lower concentrations better than others. Okay? So water quality parameters affect respiration, feeding, metabolism, reproduction, and waste removal from the environment. So it affects a whole range of things. Water quality determines the ultimate success or failure of an aquaculture operation. Because if you have poor water quality, your organisms will not grow as well, right? And in extreme cases, they could die and it could lose their entire production. So the farmer must measure, record, and manage water quality all through the growing season to assure good growth and to avoid stress and death of the farm species. So record keeping is very critical, right? And you could actually use the records in case you have a problem within your system. You could use the records, you could go back, you could see when your parameters were starting to go out of balance, right? If you keep in good records, if you know exactly when your water quality parameters started to go out of range, you could troubleshoot easier now. You could look at your system now and go back and be like, hey, I wonder what happened differently during this period of time, right? And let me say, for instance, you realize now your ammonia levels start to go up real plenty within your system. And then when you go back and you check and you realize it's going beyond the range that is tolerable for your fish or is recommended, you realize that you increased feeding. Yeah. So you know that the reason why the ammonia increases because they had more food being input into the system. The fish was eating more, they're producing more waste in the form of ammonia. But then if they're producing more ammonia, that means the ammonia should have been converted because they have a biological filter, right? And while the fish producing more ammonia, have more conversion. But wait, you're not having more conversion because the ammonia level increasing. So you know now that one, the only thing that changes is they increase their feeding. So your fish produce more waste, but the waste is not being in the form of ammonia, and the ammonia is not being converted. What is responsible for your ammonia conversion? Your biofiltration component. So that means now you need to go and double check and troubleshoot your biofilter component now. You go on and you realize, well, look, it not fouled everything in it, it got it operating, it aerated everything, right? So nothing physically happened to the biofilter. But what could account for the fact that the ammonia increasing and it not being converted is the fact that your biofilter now is undersized and it's not converting the quantity of ammonia that your fish producing. So you see, really taking records and stuff like that can help you to troubleshoot the entire operation and prevent catastrophic losses, right? And it can really help ensure the success of your enterprise, right? So a lot of persons who go into aquaculture, they take these things for granted and they're not able to pinpoint or to troubleshoot because these things does happen, right? And you really need to be on top of your game, especially with water quality. Because when you're dealing with things like ammonia and stuff like that, these things are very toxic to fish. And sometimes you get an ammonia spike and it will just take you hours and you could lose your entire tank of fish. Every single thing could die. Right? So you gotta really be on top of your game, records everything, and keep your water quality within the range that is recommended for that species. Right? So again, records is very important. So how do we know when water quality parameters are good and how do we know when they are bad? Right? So again, every particular species has a recommended range and there are these things called testing equipment that we could purchase and we could utilize to test the water quality parameters to know what values they are. And then we could reference it to our recommended ranges for what we are growing and make sure that they are within those ranges. Yeah. So the first kit to the top, the one with the little blue case. Yeah. So that is a hack test kit, right? It does have a variety of water quality parameters is what we use at the lab at UE, right? Cost is about $3,500 to $4,000 for the entire kit, but each you will get hundreds of tests from each for each parameter. Yeah, but it's one of the more accurate accurate type test kits, and this will measure alkalinity, ammonia, nitrites, nitrates, etc., etc. Yeah, the photo to the top right is a dissolved oxygen meter. So you could actually take that, put that probe into the water, and it can tell you what the concentration of dissolved oxygen is, what the salinity is, etc. The meters to the bottom, relatively inexpensive, right? So those can measure things like pH. Yeah. Some meter like that costs like $185, etc., 200, somewhere around there, right? The photo to the bottom right is a bottle, right? And is a testing strip, right? So basically, you notice you have different colors, little pads on that strip. So each one of those pads represents a different water quality parameters. So those little test strips come with multi-parameter readings. So you can between one strip and you can get 5 readings for 5 different water quality parameters. Cheap, simple, and it can give you a good general idea of what your water quality parameters are like, right? It's not as accurate as the kit to the top left, right? But is a good is a good tool to utilize. So the first water quality parameter we're going to touch on is temperature, right? Temperature is perhaps the most important water quality variable because it directly or indirectly affects other water quality variables, right? For instance, oxygen, dissolved oxygen. Temperature and dissolved oxygen shares an inverse relationship, meaning if one goes up, the other one will go down. So when temperature of your water rises, the ability of your water to keep or to hold dissolved oxygen diminishes. So the higher your temperature, the less dissolved oxygen you will have in there. And dissolved oxygen is a very critical water quality parameter. Yeah. So again, the most important water quality variable will be temperature. It can directly or indirectly affect other water quality variables, natural productivity. If you look at ponds and you want to get algal blooms and things going to maintain your water quality, temperature does affect that as well. So also directly affect your culture species. Yeah. So if the temperature goes too low, the species will become, it's like caimans, like think about water go so low is the organism cannot operate or function optimally. They will kind of become kind of like how like during winter time, like you would hear about bears going into hibernation because your body temperature, your metabolism, everything slows down. Right. So too low temperature problems, too high temperature problems. So temperature affects feeding, reproduction, and immunity. It affects metabolic rates of fish, either increases or decreases with temperature change, right? So as I say, if you go too low, if you go too high, it can become problems. Each species has a temperature range or has temperature ranges for optimal growth and reproduction. So warm water species grow best above 70 degrees Fahrenheit. Cold water species grow best below 70 degrees Fahrenheit. And cool water species grow best at mid-range, anywhere between 72 to 82 degrees Fahrenheit. So like in the Caribbean, we would grow mostly, or we would grow primarily warm water species because our external environment will dictate a warm water type environment. Yeah, we do have cold water and we really do have cool water now. Because we have very limited extremes and fluctuations of ambient temperatures. Yeah, even though temperatures goes down in the night, is not that much to see that the water will go down to being within that cool water type level, and even so it will not maintain it throughout because at daytime the water will heat up back again. So we are primarily warm water. So our species that we could culture will be primarily warm water species. right? So again, I mentioned this, temperature affects dissolved oxygen, right? It affects the toxicity of ammonia as well. Ammonia is already bad on its own, right? But if you have higher temperatures, the ammonia can take a form that will be even more toxic to fish, right? So drastic temperature changes can be fatal to aquatic animals as well. If you all, I don't know if how much you will ever mind like aquarium fish, right? Or you may or may not have come across this before, but the recommended thing is you buy a fish in the pet shop, they put it in a bag, they put oxygen in it, right? So the first thing is you use an oxygen tank. They will fill it up inside of your bag. So they will increase the amount of dissolved oxygen within that water. So you're maintaining your dissolved oxygen, right? Um, the next thing you do, when you take that bag now and you reach home, you don't just open the bag and pour your fish into your water. It's always recommended you take the bag and you rest it to float within whatever aquarium or whatever you're introducing the fish to. You place the bag with the fish and that water to float in that water, right? The reason being is that what you want to do is acclimatize the fish, and you want the water temperature of the bag to become the same with the water temperature that you introduce to the environment that you're introducing the fish into, right? Because if you take it straight from the bag and the temperature difference now is great, you could shock the fish and the fish can die. That is why a drastic temperature change can be fatal. So that's the reason why you just take it and you just put the bag in. So you can kind of, anybody ever do that before here, boy? Okay, so I guess not. You all here, am I right?
Yeah.
Yeah.
Okay, great. Thanks. I just making sure because it's really cartel sometimes. Right. So managing water temperature is economically unfeasible in outdoor aquaculture. So like, let me say, for instance, we live in a temperate country, right? And it's winter time. We could still do aquaculture and we could still culture warm water species. The reason being, we could do it indoors and we could use heaters, just like how you have a house, like in a temperate country and it's winter time and you can heat up inside of your house. Right. You can actually heat up your facility, you can heat up your water, and you can keep the fish within the temperature range that you want. So you could do those things with tank-based type aquaculture systems. However, you can't do that with an outdoor pond. Like, we discovered pond culture and we had those levy type ponds out in the open. There's really no way you could really manipulate that temperature. Yeah. So depending on which part of the world you're from and whatever the ambient air temperature, the ambient temperature is, you get a species that's suited for that. Because there's no way to change that temperature of that water feasible enough to grow any other type of fish, right? But um, let me say in the States and it's very cool and it's very cold, and you want to grow warm water fish, you could still do it because you can manipulate the water in a tank, but not a pond. So the other water quality parameter is dissolved oxygen, right? Now, dissolved oxygen is affected by other water quality parameters, namely temperature that I just mentioned to you all. When you rise in temperature, less dissolved oxygen, lower temperature, water could retain more dissolved oxygen. Another thing affects dissolved oxygen is salinity, right? So salinity is like, think about fresh water like in a river versus the sea, the ocean. The ocean has a higher salinity. It's more saline, there's sodium chloride dissolved within it. Yeah? So salinity affects dissolved oxygen. The higher the salinity, the less dissolved oxygen can be retained within that system. Elevation also affects dissolved oxygen. So let me say you're going up a tall hill, like a high mountain. The higher you go, the harder it is to breathe. because you have less dissolved oxygen at higher levels. Yeah. So again, the higher the elevation above sea level, right, the less dissolved oxygen you have available as well. Okay? So these three factors increase it affects dissolved oxygen, right? So fresh water at sea levels holds about 9.2 parts per million, right, at 68 degrees, and at 7.6 ppm at 86 degrees Fahrenheit, right? So you have water at the same level, the same height above sea, so fresh water at sea level, right? All you're doing is varying temperature, and you realize the amount of dissolved oxygen is a big difference, 9.2 to 7.6. Yeah. So fish become more active and increase their metabolism as temperature increases, right? So the increase in metabolism also means an increased requirement for dissolved oxygen. So again, you see how all these things interrelated, right? So again, you need more, DO means dissolved oxygen, right? It stands for dissolved oxygen. So you need more dissolved oxygen as temperature rises to grow muscle tissues, etc. Minimum tolerable dissolved oxygen levels increases with a rise in temperature. Okay. Click the wrong one. Right. So remember, I told you all that oxygen is affected by salinity as well as temperature. So this little table here basically just gives you an idea of how much oxygen you can have within your water based on what the salinity is like, right? As well as what the altitude or the height above sea level is like. Okay. So temperature, salinity, and altitude, and this is how it affects dissolved oxygen. So let me say you look at a temperature of 68 degrees Fahrenheit. At a salinity of 0, water will have 9.2 ppm of dissolved oxygen. ppm is a measure of concentration. So you have 9.2 parts per million, right, of dissolved oxygen. At an altitude of 0, which is at sea level, you will retain this 9.2 percent or 9.2 ppm of dissolved oxygen. If you keep the same temperature, the same salinity, right, but your altitude increases to 1,000 feet above sea level, you now realize that your dissolved oxygen now will be 8.8 ppm as opposed to 9.2. All the other variables are the same, but your altitude changes. It increases, the amount of oxygen decreases. If you go to 2,000 feet above sea level, the amount of oxygen can remain in the water also decreases as well. Likewise for temperature as well. If you go up to 71.6 degrees Fahrenheit, right, at the same 0 salinity, before you would have had 9.2 ppm of dissolved oxygen. Now you have 8.8 because temperature now, right, increases. So you have less oxygen. Yeah. So, you know, you can go through the chart, see at what temperature and what salinity, and how much dissolved oxygen you can have. And again, an increase in temperature, increase in salinity, increase in altitude, all reduces the amount of dissolved oxygen that can be within your system. So these are some dissolved oxygen ranges for cultured fish. Again, remember, say fish is being used loosely. So it also refers to like shellfish, crayfish, those things. Right? So 0 to 2 ppm, small fish may survive a short exposure, but lethal if exposure is prolonged. And 0 to 2 ppm is lethal to larger fish. Right? So all basically they're saying is that if you have a very low dissolved oxygen within the 0 to 2 parts per million concentration range, it can be detrimental. 2 to 5 ppm, fish will survive, but growth is slower, right? If it prolonged, it could become very stressful because the fish not really quote unquote breeding the way that they're supposed to breed, right? And aeration devices are usually required to keep or to bring back that dissolved oxygen level. If you have your concentration of dissolved oxygen around 5 parts per million, close to saturation. Saturation meaning you have the maximum amount of dissolved oxygen that can be retained within the water column. That saturation level is vary based on elevation and all those things, right? But anywhere between 5 ppm and above is good for most all aquatic species. So it's really the desirable range, 5 ppm and above. So let me say you set up an aquaculture system. You put in your fish, your tested dissolved oxygen is 4.5 ppm. You need to increase that to at least 5 or above. So you add additional aeration devices. They get a bigger air pump. You increase water exchange. You know, you do things to increase the dissolved oxygen. So the ppm will go to 5 and above. You test it back with your meter. Once it's above, you have no problem anymore. So these the importance of testing and all these different setups. Right. So these are concepts for some that I need to introduce you all to. Your biological oxygen demand, your BOD. So basically, your biological oxygen demand is a measure of the oxygen used by all organisms in a pond. Right. So let me say you have a pond, right? And you have your fish in there. Remember I told you all when we did the biofiltration component that you have bacteria, right? Beneficial bacteria, your nitrifying bacteria, and those bacteria are aerobic bacteria. Yeah. So meaning they need to utilize dissolved oxygen to function and to exist. Right. So in addition to having your fish, you have bacteria that use an oxygen as well. If you have algae within your system, yeah, and you have a little green water taking place, guess what? Your algae also use an oxygen as well. While they're producing oxygen during the day, at night time, they utilize an oxygen for respiration. So your biological oxygen demand is the sum total of all the oxygen that each organism within your system is utilizing. Yeah. So when it is your set up a system, you also have to cater for the fact that there are other organisms within the system utilizing oxygen. Yeah. So one of the critical things, especially if you have a green water system, yeah, is that during the day, everything could be fine, completely fine with your system and your fish, right? So let me say you have a green water system at daytime and you have a high algae content, phytoplankton content within your system. During the day, these microscopic plants photosynthesize. They produce they produce oxygen and they utilize carbon dioxide, right? So oxygen is a byproduct of photosynthesis. But guess what? At nighttime, could they photosynthesize? Nope. But they continue to respire because all organisms respire day or night. So at daytime, they're adding oxygen to your system. So your fish doing fine because they get oxygen from the phytoplankton and they're utilizing less oxygen than they're producing. At nighttime, they cease producing dissolved oxygen while they continue consuming dissolved oxygen. So you realize now your dissolved oxygen level could go critically low at nighttime because you have your fish using oxygen, your plants still using oxygen, but they're no longer producing oxygen via photosynthesis. And you have your bacteria still using oxygen too. So the biological oxygen demand at nighttime will be felt greater, right? And your level could drop so low that it could cause problems for your fish and it could end up with fish dying overnight from a lack of dissolved oxygen. However, during the daytime it's fine, but at nighttime it could become extremely problematic. Yeah? Right? So dissolved oxygen falls at night since all organisms are respiring. Yeah? Right? So we covered that. Diffusion and wave action adds oxygen into your system as well. So like if you have earthen ponds, right? Sometimes it's not really necessary to add aeration devices into it based on how much fish you have stock. Because remember, you have extensive stock. Pond culture is extensive. So you do have a high density of fish. So you have more volume you have a greater volume of water per fish, right? So they have a greater area in which they get oxygen to breathe, right? And when you have ponds and you have wave action taking place, like the breeze blowing against the pond and you see these ripples and then it will crash against the walls of the ponds, that action adds oxygen into the system. Yeah. So diffusion, wave action, all of these things add dissolved oxygen. So in most instances with ponds and things, they get the amount of oxygen that they need. Yeah. So this photo giving you a little idea on what the effects of low dissolved oxygen on fish looks like. This is something called piping, right? Anybody can tell me why they think the fish basically coming up to the surface of the water? Well, we already know that is because of low dissolved oxygen, but why the surface? Yeah, correct. To get oxygen, right? But the thing is, even a little more than just get oxygen, right? So yeah, they come in to get oxygen, but remember, fish have gills. They can't breathe air like what we would do. Yeah, so we have lungs, so we would breathe air, atmospheric air. Fish can't breathe atmospheric air. They dependent on water passing over the gills. So they can absorb the water through that. So coming to the surface, they can't breathe air from the air. However, right, at the surface is where we have the highest concentration of dissolved oxygen. So they're not coming up there to breathe air like from the atmosphere. They're coming up there because the surface, the interface between the air and the top of that water, like the top layer of water, had the highest concentration of oxygen. Because the fusion of oxygen from the atmosphere takes place at the surface. So let me say throughout that whole water column is it have next it almost negligible, no dissolved oxygen. So the fish swimming until it comes straight to that, just that very thin layer to the top. And that's where you had the highest, so that's where they will accumulate the most. And that's why they come to the top. Not necessarily to breathe air, like come to the surface and take some air from out in the open. No. They're still only able to get oxygen from the water, but that surface layer has the highest concentration of oxygen. And tilapia do something called piping. If you notice this third fish from the top here with the mouse pointing, you see how the mouth kind of open because they're trying to gulp that at that surface there to see how much water they can get moving over the gills. And when tilapia dies from doing this thing called piping, which is opening the mouth and trying to gasp for oxygen like that, they usually die with the mouth open like that. So that's a good sign of fish dying from low dissolved oxygen. Yeah, so this is actually one of my photos that I took from by a client, right? He had so if you see this black thing to the back here, this black part of the background, that is actually a fish tank. And he had a green water aquaculture system. Yeah. So at daytime, he had no problems because the algae producing oxygen and everything. But the algae became very dense. The water was extremely green. So at nighttime, what had happened is that because it has so much algae, they utilizing out all the oxygen from the system, leaving very little for the fish. And the fishes were suffering at nighttime from a lack of dissolved oxygen, and they basically piped and died. Like every night was a whole set of fish mortalities he was getting. Until I went on a troubleshoot and there were a couple of things I recommended to him, increasing aeration and all these things to help with the dissolved oxygen problem. Right, so signs of low dissolved oxygen. So the fish not eating, acting sluggish, gasping for air at the surface, the group near the water inflow pipe. So that's a real good sign that you dissolve oxygen low. Because where, like let me say you have a tank and you have water coming into that tank. Where that water enter in the tank and splashing and making contact will have the highest concentration of oxygen because of agitation. So if you find you see all the fish close to there, that means you don't have sufficient oxygen in the rest of the tank. Low oxygen could also lead to slow growth in your organisms as well, right? And outbreaks of disease and parasites could also occur because the fish become stressed. When they become stressed, the immune system drops, and that could also lead to further problems, right? So proper water management prevents the problems from depletion of dissolved oxygen. Management techniques include monitoring DO at critical times, right? So when is the best time to check the dissolved oxygen? Morning time. You can check it morning, noon, and evening, but morning and evening is most critical, right? Because if you have a green water system at morning, like as soon as the sun starts to rise, right before sun rises, you will have the lowest concentration of dissolved oxygen, right? Because at nighttime, all the organisms will be using oxygen. So the first thing in the morning is the best time to test to see the lowest concentration you have within the system. If your lowest concentration is under 5, you need to add aeration into that tank at night time. Yeah. So it's a good time to know when to add oxygen, because that's the lowest point. In the evening time, you have your highest concentration of dissolved oxygen. Because if you have algae and plankton within your system, you will have the sum total of oxygen produced for the entire day, and it will be at the peak in the evening. So you want to know your maximum and you want to know your minimum. Yeah. So those are the critical times you can measure your oxygen to know, have a good feel of what is going on. So another thing you want to do as well is avoid overfeeding. If you overfeed your fish, then they will basically utilize more oxygen to break down that fish food. Some of that fish food itself might break down within the system and utilize oxygen. So you want to avoid overfeeding, right? A key thing, if you realize that dissolved oxygen within your system is low, right? Is low, you stop feeding one time. Because what happens when you feed fish and they start to eat that food, they start to respire because they start to utilize oxygen for the breakdown of that food. So that's the worst thing to ever do when you have a low dissolved oxygen problem. So let me say you have a fish tank and current gone and you have no backup power in place. So your aeration devices and your pumps not working. The biggest mistake you can ever make is to pass around the same time and feed your fish. Yeah, because in addition to the oxygen being already low because you have no aeration taking place, you're going and further utilize all the oxygen because when the time you feed that fish and you consume that food, you're going and utilize way more dissolved oxygen to break it down. Yeah. Always maintain proper stocking density as well, right? Within your system. If you overstock your tanks, then you have more fish than the system could maintain. So yeah, it could only have your dissolved oxygen could only become so concentrated within water, a standing body of water. It can't go beyond a certain amount. And if you overstock fish, then the system itself wouldn't be able to provide that amount of oxygen. If you have ponds, you want to avoid over-fertilization because over-fertilization would lead to algal blooms. And if your algae becomes too much, remember I tell you, if you have too much algae at nighttime, problems. If you have a pond and you realize the oxygen low, add some form of aeration into it. And you always keep your water circulating so you increase the homogeneity of your environment. Right? So to add dissolved oxygen, you can add aeration devices, right? So when we cover earlier when we did recirculating systems, we would have seen air pumps, air blowers, aeration devices. So Always increase the dissolved oxygen by adding aeration or oxygenation into your system. Aeration is using atmospheric oxygen. You use things like air blowers, air pumps, air stones, and stuff like that to increase bubbles and air within your system. Oxygenation is adding pure oxygen using oxygen tanks, and both is a means of adding oxygen within your system. Always have a backup source of power because you always want your aeration devices to be working, especially if you have a heavily stocked tank. Right. So we will hold up today, right? We will hold up today on water quality. We will continue with that and move on from the next lecture, right? At this point, the last couple of minutes, I would just like to discuss the group and the individual projects that I would like you all to do, the assignments, right? Right. So we stop on alkalinity. So we will pick up on there from next class. Right. So two of the assessments for this course will be via a group project as well as a an individual assignment. Yeah. So the group project will be worth 20% of your final grade, and the individual assignment will be worth 15% of your final grade. Okay. So basically for the group project, right? So we will basically divide the class into two groups, right? And each group would select and work on one topic, right? One of the requirements is a short PowerPoint presentation, approximately 20 slides, which will be prepared and presented by each group via Zoom, right? And a write-up is also to be submitted along with the PowerPoint. The write-up must cover all core areas of the research topic, right? So be creative. Pictures can also be included. It will help as well. Yeah. So for the group projects, right? So I can leave it up to you all to find yourself into groups, right? So maybe well, I'll actually get us WhatsApp group done, but you all could email me the list of, split yourself up into two groups. For those of you who can find yourself into groups, I'll just basically put you all in at random, right? But other than that, I'll give you the opportunity to form yourself into two groups, right? So we could work on ascertaining who in the groups maybe within by midweek or to the end of the week, right? But in any case, the first group project, right? Group project 1. So the title for this project is Discuss the Diversity of Aquaculture Species and Production Levels in the Caribbean, right? Now remember, I told you all that in Trinidad we do primarily tilapia, right? But other than that, we do conch, we do crayfish, we do um, some cascadoo as well, which are the primary species. However, we have different aquaculture species used throughout the Caribbean. Yeah, some places do turtles and different things like that, right? So for this particular group project, you will discuss the diversity, the different types of aquaculture species that is being utilized throughout the Caribbean. So you do some research, see which country growing what the production levels are, etc. Right? And basically that will be the foundation on which you will build for this project. Students must be able to define diversity in the context of species being cultured, right? So you must list the different species, finfish, shellfish, plants, etc. that will account for 6%. The different strains. So like if you have tilapia, right? So tilapia, you have, all right, yeah, tilapia, but you have different strains of tilapia. So what type of tilapia is cultured within Trinidad? We have red hybrid, we have Nile, these different things. So you're really going in depth a little bit into the different species and the different types of different species and stuff like that. Really discuss what is available locally, what is regionally, people get production um levels and those kind of things. Be creative. You could use tables to present the information. You could do those kind of things as well. Pictures as well will help also, right? So also the estimated production levels of the various species in their respective countries. So like every say, the limit tilapia, talk about Trinidad, see what data you get, see what they're doing in Jamaica. Jamaica does a lot of tilapia production. And I just use an examples. Yeah. So you really discuss and you really get into it. But the title again is Diversity of Aquaculture Species and Production Levels in the Caribbean. Group Project 2, right? So one half of the class will focus on that. The other half of the class will discuss the diversity of aquaculture systems in the Caribbean, right? So basically, students must define the Caribbean territory and aquaculture, right? So again, remember we said we have different types of aquaculture systems. So we have pond culture, we have tank culture, we have cage culture, right? So you really want to go now and do research now into the Caribbean and see which country utilizing which type of aquaculture system, etc. Right. Because I given you all a chance to put yourself into groups. You don't have to be the full class. So like let me say like about 3 of you all are good friends. I want to be in a group or something. And then from there I could try to split everybody. So again, you have the opportunity to try to find yourself into a group, right? Kind of the class half and half, right? If not, then I could always put you all into groups. Okay. And we will do that before the end of the week. So you can start to get us going. So like today is Monday. Let me say by I see like a couple people missing. So time I'll send this out the group projects and stuff via email as well. Right. So let me say by Wednesday, Tuesday, we should be able to know which groups we are in. So we could move forward with everything from there. All right, Jared want to be in group one. All right, no problem, Jared. So definitely you will be in group one, right? So see which topics resonate with you as well too, right? And you can find yourself in that particular group. Yeah. Right. So let's see. So that was that for the group projects, right? So group project 2, define Caribbean territory and aquaculture in general. State and define the different types of aquaculture systems, right? So you could talk about pond culture, we're doing cage culture, etc. Right? Again, elaborate on the different production systems in the Caribbean territories, ponds, tanks, aquaponics. Yeah. So you can kind of focus on these because these are some of the major areas or major types of systems. Remember, I told you all pond and tank is the most common, but there are other types of systems like cage culture, like raceways and somebody. So you would see somebody else when you do your research, right? Also include aquaponics as well. Yeah. While it's still a kind of way of doing tank culture, I included it as a separate type of system because it's becoming very popular and is a very interesting topic as well too. Yeah. For the student assignments, right? Any questions on the group projects, like on what I have here pertaining to it? I mean, if you go through it and then you kind of find yourself in a group and you have further questions, no problem. I will guide further. Yeah. Due dates. Typically these will be due somewhere around a week before your final exams. I'll give you all maximum time, right? So I could be able to correct it and have everything put together before your finals. Yeah, because I know you all have other stuff going on as well, so I don't really want to give you too short of a timeline. Plus, while the course goes along as well, or we're covering different topics, it will add towards your group, yeah, add towards your projects as well, especially when we do aquaculture species. Yeah, you would see some different types of species and those kind of things. So the longer time you have is for your benefit. Student assignments with 15% of your final grade. Yeah. So for your student assignment, assess current aquaculture species used for food production, current, past, and future. Meaning, right, you could select tilapia and you could do an assessment of it, right? What is the production values like in Trinidad? What is like in Guyana? What is like in, well, yeah, well, where is like, sorry, like in Jamaica and Grenada, right? Different cultures. So you could talk about all different aspects of that particular species. Yeah. So basically, for this particular assignment, each student must choose a species and propose why they chose that particular species. Yeah. So let me say somebody choose tilapia, um, you choose crayfish, macrobacterium, cassinus. You could choose prawns, macrobacterium rosenbergi. That's some of the things that are cultured within the Caribbean here. Yeah. So you say why you choose your species. What why you choose this? Because you think that it has good potential. It has a lucrative market. All the reasons why. However, you could also suggest a species. It don't have to be cultured here in Trinidad. You could say, well, I think a piranha is a good species for aquaculture. It could be anything. And say, well, a piranha does grow to this size within this amount of months. It is feed on food that is relatively inexpensive because they're carnivorous. We could just feed them scraps from um, fish waste from, you could choose a species that not currently being done and use that as your proposed species as well too. So that could be a future species. It could also be a species that was done in the past that never had good success, but you decide, hey, I think we could put back that into aquaculture. Yeah, and you can talk about it. Identify which countries, geographic locations these species are being cultured, right? Is this species indigenous to the countries where it's being cultured, right? If this species is currently being cultured, then evaluate the status of its production, commercial, what type of production, how much people doing at subsistence level, etc. Right? So you talk about threats that might be faced in this particular species in terms of getting it involved, getting it put into production, your potential markets, right? If this species is not currently cultured, then state their aquaculture potential, like what I was not talking about the piranha, right? As well as the potential pitfalls. So like we say doing piranha, one of the pitfalls they can't really get escaping out into the environment. It could cause problems, right? So this might be an issue. So these are some of the challenges, but opportunities are if we could keep it in a controlled environment, this kind of thing we could really add on to diversity. So again, you could be creative. You're not limited to these points, but these points what I put here must be addressed, right? Anything other than that will add to your benefit as well because it could gain you some extra marks, right? So the body of the essay should be approximately 1,500 to 2,000 words, yeah, when you're doing this assignment, right? So yes, so you can start to think of different species, any species again in the world, right? You think about it, and then you have to check the applicability um to the tropical environment. Yeah. So it must be a warm water species as the only requirement. Yeah. So if you all have any questions on this, feel free to even while you go along outside our class, you can email, you can message me, WhatsApp, you can give me a call. I can help guide you on this as well. Same thing for the group projects as well. Okay. So I know you all may not have any questions on this right now, right? So if you don't, then no problem. As soon as questions and things come forward, you can ask. Right? But any questions on what we covered so far with well, about these two projects? All right, Sasha Marie, group 2. Right. So I'm gonna stick a little note. Right. So good. So again, right. So you all could do it like that as well. If you have a particular topic that you're interested in, you can just you could just basically send my email or send my WhatsApp message when I put up the group. Yeah, make it send it through WhatsApp as well. So give it some thought into what you think you might like to do in terms of the group project, and you can find yourself in groups, and I will help guide further on these topics as well. So you won't just be lost in the water. So we'll guide you throughout because I really want you all to really get into the depths, and you can start to see the potential of aquaculture that is for the Caribbean. Yeah. Any other questions before we close off? Right. So group 2, Sherelle. Right. So you can take the next 2 minutes if anybody want to be in a particular group. They could say so now. If not, then it can message. I could see group 2 assignment. No problem. Group 2 assignment. This one. Discuss the diversity of aquaculture systems in the Caribbean. No, I'm going to email this out to you all now. Like, no. So I'll send this and then, well, later on, I'll send the slides and thing from today's session. Right, but I'll send this to you all now so you can have a look at it, and you can decide probably by tonight or tomorrow. So, right, so this is group project 2, and this is group project 1, diversity of aquaculture species and production levels in the Caribbean. Let's go back and let's check. Okay, Tiana is group 2. No problem. All right, nice. All right, guys. So we'll close off there for this evening. I will send this out to you all now. And if you have any questions, you can touch base with me before next session, and we could talk about it some more. Right. So other than that, you all enjoy the rest of your evening, and your slides and stuff will be sent via email. And well, hopefully I would have everything up on my learning. I should have my learning functioning by this week, yeah, and I'll upload everything. Yeah, so good night, and until we meet up next week.